So this is Geometry Semester 2. It's the 4th unit called Conditional Probability. It's the 3rd lesson called Counting Problems Practice. This is on creatormath.com or creatormath.weebly.com, whichever one you can get to by searching on Google. And it's under the Geometry tab. The instructions are copy the following problems 1 through 4. I think it's more than 4 problems, you guys. It's 1 through 14. 1 through 14 into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. Don't forget the notes are in a separate file, and in fact I can show you that right now just to model that a little bit. If you're on creatormath.com, remember that you'll show up on the home, and remember you may have to type in creatormath.weebly.com for that. creatormath.weebly.com to get to it. You're looking for the Geometry tab, and it might be under a different one. See how there's a drop-down menu for Geometry? Go to Geometry tab, pass by the vocabulary stuff, get down to the table of contents. You'll see we're in Semester 2. This is all the table of contents, which goes on pages 2 through 6 of your composition book. And you copy in all these things all the way down. So this one's special rights. Each one of these is a unit. Solids and constructions, volume. Here. Conditional probability, that's the unit we're in. You can see there's permutations, combinations, and counting problems. That's the one we're in now, the 3rd one. There's notes, problems, and video solutions. I'll put the video solution, which we're making right now, up once it's done, but here's the notes that go on those pages 85 and 86 of your composition book. And it might take a second to load, and sometimes I've had to reload these, but this is a picture of the board. You're putting these notes in. And we can use these notes to help us answer these problems, right? There's a lot of information in these notes, like vocabulary, what a factorial is, what a combination and permutation is. It's not in the problem sets. That would be in the notes that go on those pages of your composition book. Also some additional problems you can do, and etc. All right, so let's go from there. Let's start on this one and see what this says. For the following, state if it is a permutation position with repetition, a permutation position without repetition, or a combination. And we'll see by the different practice problems, hopefully you get some idea of the different options involved here. But the order of selected items matters, but there's no repeating items. So anytime the order matters, and this is in the notes, it's a permutation, and they're telling us right out there's no repetition. Right, so this is a permutation with no repetition, and they start us out very gently with these problems, basically asking us a question and then telling us the answer. For the following, state if it's a permutation with repetition, a permutation without repetition, or a combination. So this one says the order of selected items matters. Again, just like the prior problem, when the order matters, it's a permutation. And then they tell us straight out, there are repeated items. So it's a permutation with repetition. Repetition means repeating. The reason position is in parentheses because that tells us the two P's match for permutation and position. That's sort of a memory aid to help us know that order of selected items matters. Right? The position of those items coming out 1, 2, 3 matters. Number 3, for the following, state whether it's a permutation with repetition, a permutation without repetition, or a combination. The order of selected items does not matter. Ding! That's a combination right off the bat. That's all we need to know. If the order does not matter, we don't care what comes in first, second, and third. We just want to know what we got when we're done. Number 4, if the order of selected items matters, which makes it a permutation, and items don't repeat, so it's a permutation without repetition, check. What formula do we use? And just check back at the notes for these, right? Permutation, no repetition right here. It's n factorial over n. It's a little bit better to see that. N factorial divided by n minus r parentheses factorial, right? And sure enough, there it is right there. So take the notes, follow those, and use the notes as you do these problems, or use this video as you do these problems. If the order of selected items matters, ding, so permutation, and items repeat, so permutation with repetition, they want to know what's the formula. So we have a permutation with repetition formula we use, and it's this one right here, n factorial over repeat 1 factorial times repeat 2 factorial times etc. So here it is right here. Then they're going to give us a couple of examples with these problems, and we'll try to do the math on our calculator for them using the factorial key, which this is the third lesson in this unit, so you should have a little bit of an idea what factorial is by now. If we are selecting a group of objects at a single time out of a larger group of objects and are not concerned about order. So I already know it's a combination, because order, if we're concerned about order or position, it's a permutation. If not, it's a combination. Another way to think of combinations are that we're selecting a smaller group out of a larger group. What's the formula used? So again, we're just going to go back to the notes, because this is an introduction for us into this, this subject of statistics, all right? So here we go, combination right here. You just got to find it in the notes. NCR is the abbreviation that you set up, but it's n factorial over parentheses n minus r parentheses factorial times r factorial. Right. Remember, for me, it's always my first choice. For you, they'll be random in random order, so you have to look a little bit closer. What are the number of permutations of 8 objects taken 3 at a time? In other words, how many different orders can 3 items have when we select a single item out of 8? Hint, the formula for finding it is n factorial over n minus r parentheses factorial. So here it is. Here's the setup. There's an 8p3. That's our setup. 8 factorial goes on top because that's the n. See how the n lines up before the p? So n factorial is 8 factorial. Then we have an 8 minus 3. R is the number of items being selected out right here, 3. So 8 minus 3, which equals 336. So for this, definitely go to your calculator, and you definitely want to try this. Go to your calculator, make sure to clear everything out, turn the calculator sideways. I don't know if you could see that, do the switch. All right, so we have, by turning it sideways, we now see things like trig functions, and on my second screen, see this x factorial or x exclamation point, that means factorial. And we explained it in the other lessons, but basically speaking, if you have a 5 factorial, that equals 5 times 4 times 3 times 2 times 1. If you had a 4 factorial, that would equal 4 times 3 times 2 times 1. If you had a 3 factorial, it equaled 3 times 2 times 1. Now we could do that. We could take 5 factorial and we could go 5 times 4 times 3 times 2 times 1 and get 120. See it right there? Or they give us this cool key and you say 5 factorial and it does it for us and it does all the work. That's what a calculator should do. So let's try to plug in 8 factorial, clear, 8 factorial divided by, right here, 8 minus 3 is in parentheses. So we're going to do parentheses, 8 minus 3 parentheses, then put the factorial on the outside of the parentheses. 336 options are what we have for this situation. And there it is, 336. So practice on your calculator and make sure you can use these. All right, given the word mom, the order matters and the m's repeat. If there are 3 letters, M-O-M, if the 3 letters, M-O-M, are selected from a larger group, it is a permutation with repetition, right? Because the m's can repeat. Technically, the m's could be reversed to provide 2 selection options, but reversing the m's does not matter because both produce the same effect. Therefore, we say that the m's can repeat up to 2 times. We use a special formula to deal with the special situation of a permutation. Repetition is n factorial over repeat 1 factorial times repeat 2, etc. So we have 3 letters, so therefore we have a 3 up top. And then we have the m's, which can repeat twice, so 2 factorial on the bottom. So we're going to simply put into our calculator (3 factorial divided by 2 factorial). All right. And we get a 3 right here. And that's what we got right here. 3. All right. So this one is this answer here. All right, let's go to number 9. 9 says, how many permutations are there in a statement of, in the state name of Mississippi? M-I-S-S-I-S-S-I-P-P-I. So how many letters total? 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many repeat? We got 4 S's, so there's going to be 4 repeating items there. You got 4 I's, so there's going to be 4 repeating items there, and 2 P's, 2 repeating items there. So we're going to use the formula they tell us, which is n factorial, the total number, so 11 factorial divided by 4 factorial, 4 factorial, 2 factorial. Those are the repeating S's, the repeating I's, and the repeating P's. Right? We get 34,650 options. Let's definitely put this one in our calculator. This one looks cool. All right, so we've got 11 factorial divided by 4, and let's use a parentheses down here to group together everything on the bottom, right? 4 factorial times. That way we're using a times here, and you're going to just have to work out the order of operations. If you put a parentheses around like this, then it's going to be times between these. Times 2 factorial and parentheses. Let's close it in. 34,650, check. That's the number of options you have of pulling out these letters, one letter at a time, and caring about the order, and having repeats in it. That's what the permutation with repetition does. If we are selecting out of a group of objects at a single time, if we are selecting a group of objects at a single time out of a larger group of objects and are not concerned with order, it's a combination. Another way to think of combinations are that we are selecting a smaller group out of a larger group. What is the number of combinations of 3 objects taken from a group of 8 objects? So we're going to have 3 here, and we're going to have 8 minus 3 here, and we're going to have 3 there. Let's see what they've got. Sure enough, here it is, 8 minus 3 times the 3 on the bottom. This one, be a little careful of too. Sometimes students will not realize that this is all parentheses down here. That has to be grouped in the denominator position. So this could be a little bit tricky if we didn't know that or we didn't do that. Okay, so let's take, clear? 8 factorial divided by, let's drop in the parentheses because now we're going to do another set of, I'm going to do 2 sets of parentheses. I'm going to do 8 minus 3 factorial here and times 3 factorial. And close it all in with a parentheses. So 2 sets of parentheses and nested parentheses. It's going to do this one first and raise it to a factorial. And then it's going to take this one and multiply it all together. And then it's going to take this and divide it by all that, right? 56 is right. If you get a different answer here, check your order of operations right there. How do we say 5 exclamation point, right? This is sort of a beginner's question on our 3rd lesson. Maybe it's not so difficult for us now. How are we to calculate the value? Well, we say 5 factorial. That's in the notes, and we've been doing it here for a while. And it's 5 times 4 times 3 times 2 times 1, which is 120. Remember, we have the key on the calculator. We just type in 5 factorial and it tells us 120. 5 factorial divided by 3 factorial reduces to what? 5 times 4. I'm going to tell you the answer first and then explain how it works. If 5 factorial is this, 5 times 4 times 3 times 2 times 1, and it's divided by 3 factorial, 3 times 2 times 1. These all cancel, each being 1, and multiplying 1 times 1 times 1 is 1, and what's left? 5 times 4, or we could have said equals 20 here. All right. 13. For the following state, if it is a permutation with repetition, a permutation without repetition, or a combination, we are choosing a smaller group out of a larger group, and the order is important. That's a permutation, and there is no repetition. So permutation without repetition. They're basically telling us what it is, just asking us to mark the answer. Number 14, for the following state, if it is a permutation State if it's a permutation with repetition, a permutation without repetition, and a combination. We are choosing a smaller group out of a larger group, and the order is important, and there is repetition. Once the order is important, it's a permutation. Ding. And if there's repetition, we just say with repetition. So this is out of the unit. The unit is called conditional probability here. It's abbreviated Prob, but it's conditional probability. It's the 4th unit in the 2nd semester of geometry. It's on creatormath.com, or you might have to put in creatormath.weebly.com under the geometry tab. Hope this helps.